All right, so today we're going to start into Chapter 7. Chapter 7. Okay, Chapter 7 just has a few topics. Okay. What we're progressing our way into are the molecules called the alkenes. Remember the alkene functional group? A carbon-carbon double bond. Okay? That's what we're going to be heavily getting into. Okay? So, since alkenes have at least one double bond, let's look at the composition of the double bond. Okay? So if I drew a double bond like this here, okay? Remember what the double bond is made up of? It's one part sigma bond and another part what? Pi bond. Okay. Remember the pi bond is made up of two p orbitals overlapping side by side. Okay? You got the top half overlapping and bottom half. Okay? So this middle bond here is the sigma bond. The pi bond, we view it as half of a pi bond here and half of a pi bond down there. So half and a half is one. Okay? But this is how we're going to be looking at the pi bond when we get into the chemistry of it. Okay? One of the things you want to realize about the pi bond is that we can't rotate it. You see that? If I tried to rotate that bond, it would do what? It would break the pi bond. The two would not be overlapping anymore. Okay? So when you see a pi bond, there's no rotation. Okay? You see a double bond. When you had a single bond, you could rotate, couldn't you? And so we set up what? The Newman projections. Remember those? But there's no Newman projections for these. Okay? So once you have a double bond, it's locked into place. Okay? All right, so let's spend the rest of the lecture on this second topic. And this second topic deals with naming alkenes. Okay. Quite an extensive topic, and one that will take us to the end of class. Okay. So let's look at the simplest alkene. This one here. We could also rewrite like this. Well, you have a 2-carbon alkene. So remember, 2 carbons comes from ethane, but the suffix is now different. It's ene. So this becomes ethene. Ethene. Okay? So remember, in organic chemistry, always the suffix, the ending, tells you what kind of molecule you're dealing with. Okay? Let's look at another one here. What do you think the name of that one is?
Propene.
Propene. Okay. Sometimes you also see other names. Sometimes this is also called ethylene or propylene, but we're going to stick with this nomenclature here, just the E suffix.
I have a question.
Yeah.
So really does double bond and the E?
Yeah.
I have a question.
Yeah.
So it's absolutely wrong by adding the YL?
Oh, no, it's fine, but we're just gonna stick doing it this way. I just give this to you because you'll see it used in other places, and probably in the reading of your book you'll see it. But just to let you know it's the same thing. Let's go to this one here. Okay. Do you think the name of that top one is? There you go. 4 carbons for butene. About this middle one. Yeah, the double bonds
It's just changed.
changed.
But
And
it's
changed
still the
again.
same.
Okay. So these two here are isomers. Okay? Because the double bond is in a different place. And because of that, starting with butene, I have to number where the double bond is. I've got to tell you where it is, because those two are different things. So what I do is I number the chain. Okay? I number the chain. Okay? So the number that I'm looking for is the place where the double bond starts. Where the double bond starts. So there it starts on 2. So what do you think the name of that first one will be? 2-butene. And what do you think the name of the second one will be? 1-butene. And what do you think the name of the third one will be?
3.
Yeah.
Can't you put that in?
It started on.
Okay. Here, we have to introduce a new rule. A new rule. Okay? We number at end closest to the double bond. So I have the number over here. So what's going to be the name of that? It'll be the same. So these two are the same. Any questions on that? Okay? So these two are isomers because they have a different spot where the double bond is. These two are the same. In fact, you could have taken this one and flipped it, and you would have seen it was the same. Okay? Or number the parent chain according to this rule. Okay? What we are seeing with these two rules is something that we call priority. Okay? What's the definition of priority? Do you have a priority in your life? It's what you put first, isn't it? Can you name any priorities in your life?
Organic chemistry.
I guess some butter points, huh? Okay? It's the things you do first, don't you? Okay? But a double bond carries priority. Okay? Because it dictates how you name the molecule, how you number it, and how you name it. I start with the starting number, not the ending number. Okay? Let's look at some more examples. Okay? Let's suppose we had this here. Okay, where would I start numbering this one? The left or the right?
The right.
Yeah, see that? Has priority over these. Normally, if there was no double bond, I would number from this end because the groups have priority. But now we have a new priority. Okay? Do you ever have a new priority in your life? Okay. You know, for example, you might be really hungry, so your priority is to get something to eat. But while you're on your way to get something to eat, you see a child in need on the street. Maybe he's about to get run over by a car. And so you go and grab him. You forget about your hunger. Now the child's primary. Okay? So you get the idea. Okay? Okay? It's one of the secrets of life is putting priorities straight and living by it. We don't all the times live by priorities, do we? We live by your desires, say. Okay? So here, you have what? 5.
402 heptane.
All the way out like that. Okay. Questions on that one? So again, see how the double bond carries priority, carries weight. Well, let's look at some more
Before you erase that, sir,
examples.
when we're talking about, like, when we look at,
And this one. Okay. So here we have two double bonds. Okay. This is what your quiz is on this week, just naming alkenes. So it should be real fresh if you have it today. You should eat it for lunch. Some of you are hungry. So where would the parent chain be here?
From the bottom.
Bottom up to the right.
7. Note that I could have gone this way and have been longer.
Right.
See, 1, 2, 3, 4, 5, 6, 7, 8. Oh, I got 8 that one. But what? The double bonds prioritize the parent chain. See that? Okay. So make sure you have that down. The double bonds prioritize the parent chain. So I have a 4 ethyl, 3 propyl. Then what's the parent chain? Okay. So again, the double bonds begin on 1 and 5. That's where they begin.
See?
Okay. So 2 double bonds. I have a diene. Okay. So a diene, if I have a diene, I better have 2 numbers in front. Questions on that? Okay, so you can have a diene, a triene, and so on. Okay. Another popular diene. This one here, we'll use a lot, especially in 242. So here we have 1,3-butadiene. Question?
So the diene stands for the double bond?
Stands up for I have 2 double bonds. Di, then the E, double bond. Any questions on those 2? Okay. Well, let's suppose we look at something like this. Suppose I wanted to name something like that. Now I have a cyclic diene. Where am I going to start numbering that one? Somebody raise their hand. Somebody come up and point where I'm going to put number 1. Come on up. Okay, good choice.
That's for the wrong reason.
Okay. So he thinks we can put it here.
Put it those right there.
No, those right there.
Okay, before we go on,
Yeah.
let me explain why that is incorrect, because it's a common mistake. Okay? If we put it here, okay, here's the next rule you have to make sure you know. You number through the double bond. You number through the double bond.
So you start over.
So if I started here, I gotta go through the double bond to put 2. See that? I just can't have half of the double bond. I gotta go through it. Like a tunnel.
I don't understand.
Me, I don't.
I gotta go through the double bond. Okay? So if I name give one side a number, the other side has gotta follow through with the next number. If that's better. Okay? So if I did that, I'd go all the way around. That would be number 6. So is there a better way to number? Yeah, start at the top. So if I start at the top, I got a number through it. Then I come and I get 5 instead of 6. Okay. So this becomes 5-methyl 1,3-cyclo hexadiene. Got a number through the double bond. Question?
I got a. Could you write it like cyclodihexene?
No.
No.
No. Cyclic molecule, number of carbons in the cyclic, 6, and then the double bond ending.
Can you do another one just like that?
Yeah, we'll do it now. Okay, any questions on that, or you want to do another one to get some practice? Okay. Let's try that one. Okay, where am I going to put number 1? Anybody want to give it a try? All right. Okay, she thinks right here.
I think it's on the other side.
Think over here?
Yeah.
Yeah. Yeah. Is that where you thought? Okay, because that puts the chlorine at a smaller number. If I would have started here, I made chlorine 3. Okay. So here, I get 3 chloro, 1 or 2 chloro, 1, 3 cyclo, pentadiene. Good for you. Any questions on that?
So, you want it to be top? Do you prefer it to be on that side than to be at the top? For 1?
Think here? No, you got to put one on where the double bond is. So it's got to be here, 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 here. Yeah.
So basically, just want us to start with line, with no line, and try to make whatever extra is taken off the field.
That's right. And remember, I got a number through.
Yeah, but whatever the extra stuff is outside of.
That's right, that's the second
try to
part.
make it
Right.
smaller.
That's right. So I'm going this way instead of saying this way, because the double bonds are smallest this way, and then also the chlorine is smallest that way. Okay? All right, so let's do another one here. Okay, let's just make it simple. Okay? Let's see if you can do that. Let's take a step back. Okay, good. Do it on your own. Okay, so got to number it this way here. Hopefully got that right. Okay, so have 3 methyl, 1 cyclo. Pentane, is that what you got? Okay. Not bad, but you would have missed 1 point. Let's take the eraser. Here we don't need a 1. Somebody tell me why.
It's only one thing.
Because the double bond carries
Priority.
priority. Priority. So, you see, it is automatically number 1, so there's no need to have a 1 here. If I have 2 double bonds, yes, I need to put the numbers there. But in a ring, you can write it down if you like. In a ring, if I just have 1 double bond, I don't need a number because it will always get the priority of number 1. So my other groups will be named in relation to that number 1. So that 3 tells me I'm 3 away from the beginning of that double bond. Okay, so we took a step back, but then we took a step forward. Okay. All right. Let's go into this one here. All right, now let's let's really take a step back. You shouldn't have a problem naming this one, should you?
No.
All right, what's the name of it? Okay, 2-pentene. Okay, any problems with that? Shouldn't be after all we've gone through so far. Okay. In your book, they also have another naming system that I don't want you to gravitate toward, but I'm just going to show it so when you see it, you don't say, what is this? All right? Another way to name this is to put the number before the suffix. So you see what they're doing there? They're saying at the 2 carbon is where the double bond begins. Okay? So you'll see this in your book, okay? But I'm not going to hold you to that. I want you to name it like this. Which way do you like naming? Okay, yeah. That's the way I taught you.
Oh, yeah, the way you talk.
Because you're used to it. Okay? But you'll see this in the book. But we're just going to erase it, all right? Junk out. Junk. Well, here with 2-pentene, okay? With 2-pentene, this actually has 2 isomers. Say, what are you talking about? Well, one way I could redraw the molecule is like this. I could draw it like that, or I could draw it like this. Okay, those are 2 different molecules, right? Because you cannot rotate the double bond. So I'm stuck in both cases. I'm stuck. Okay? So I have to give a way to name these 2 different molecules. They're both 2-pentene, but how can I tell the difference? Well, I come over here, and I circle, I go to both carbons of the double bond, I circle the same group that's on both carbons, and in this case, it's a hydrogen. Then I draw a line through the double bond. Those 2 groups are what? On the same side, and so this is the cis 2-pentene. Cis 2-pentene. Cis same. What do you think the other one's called? Trans. Okay, so we learned this back with cyclic molecules. Okay? So when I have the same, one of the groups is the same on both carbons, I get cis and trans isomers. Okay? I cannot convert this to that by rotating. I'm stuck in both cases, just like the ring was stuck. Okay? Let's look at another example of this. Suppose I had that there. Okay, what's the generic name of that molecule? 2 is here, 3 is here. Okay, so bromine comes first.
Yes, 3.
Okay, so we get that there. Any questions on that? But again, we can have 2 different isomers, okay? So let's draw those 2 isomers. Okay, so there's the 2 isomers for our molecule, 3-bromo, 2-chloro, 2-pentene. Okay, you can see they're different, aren't they? Okay. Changed them here. Changed 2 groups on the same carbon, didn't I? What kind of stereoisomers are those called if I change 2 groups on the same carbon and get something different? Chapter 5. Stereoisomers. These are stereoisomers, aren't they? These 2 are stereoisomers. If I change 2 groups on the same carbon, I get something different. They're stereoisomers. But I'm not calling them R and S and all that stuff. I'm using cis and trans. But here, is that cis or trans? What's different compared to over there? I don't have 2 of the same groups. I don't have 2 of the same groups. Over there I had 2 hydrogens. Here, all 4 are different. So, how do I do this? Well, what I do is I come to 1 carbon of the double bond, and I use my chapter 5 skills. Which has more priority, chlorine or carbon? Chlorine. Okay, so I'll circle the chlorine, higher atomic number. Then I come over here, bromine, carbon, which has higher atomic number. So we'll circle that. And draw a line on the double bond. What side of the line are those on? Same side? They're not on the same side.
They're not?
You think they're on the same side? Okay. They're not on the same side. They're on the same side. The same side. So this is called the Z isomer. So this would be called Z dash 3-bromo 2-chloro 2-pentene. And this is called E 3-bromo 2-chloro 2-pentene.
So with a hydrogen, so that's when you use the cis and trans.
yeah, but if you have two groups that are the same. Here, all four groups are different. Okay? So if all four groups are different, we get what are called the E and Z isomers. The E and Z isomers. Wasn't that easy? Okay? Now if I have two of the same, then I have cis and trans. Any questions? Okay. All right. So I'll let you go and we'll look to see you on